Say continuation VBScript file system operations part 2. VBScript file system operations part 2. See, in the last class, last example, data-driven testing. See once again. Our requirement is read test data. Read test data from a text file and perform data-driven testing. Data-driven testing for login functionality. Login functionality. See, first create basic test. Basic test. Activate the dialog, enter agent name, enter password, click OK, close the application, stop recording and run it once. Perform dry run, sample run, whether the script is executing without errors or not. Okay, test is ready. Next, test data. See, test data also ready. Here I used first line field header, fields header, second line onwards data. See, every line having two fields, agent name, password. Next, comma space is the delimiter. If it is data table is UFT tool feature, ready-made environment. There, tab space is the delimiter. But here, it is pure scripting. You can use any delimiter. Then you have to split the delimiter. Got this point? If it is data table, what is the delimiter? Suppose if you want to import data from a text file to data table, then what is the delimiter between two fields?
It's comma space?
No, tab space. If it is data table, tab space. Already in parameterization chapter we did that. But if it is scripting, you no need to follow any syntax rule. You can use comma or star symbol or any symbol. Getting?
Sir.
See. Next, test is ready. Test data also ready. Fetch the data and connect. See, first create file system object and text stream object. Why text stream object? For internal operations. See, here we are going to read the data. Read is internal operation. See, dem obj fso variables, obj text stream. Next, create file system object. Tell me the syntax. How to create file system object? How to set your voice is breaking. Set variable.
Obj equals to
Set variable equal to create object of class value. What is the class value?
scripting dot
Scripting dot file system object. Next, create text stream object. Set another variable equal to file system object objfso dot. See, if file exists, use open text file method, or if file not exists, use create text file. File already exists. Test data file already exists. So use open text file. Type O, open text file of file path. Next, comma, read mode. Read mode is 1. Default mode is read, so you no need to specify. Next, obj text stream dot skip line. Why skip line? See, in this test data file, first line is not test data. First line is field header. See, we need to read from second line. That's why skip first line. Next, do, otherwise you can use while when loop also, otherwise do loop also. Do while obj text stream equal to false. Next, read lines one by one. I'm taking one variable, my line. Read lines one by one. You know how to read. Variable equal to obj text stream dot read line. Next, every line having two fields. Split the line using delimiter. I'm taking one more variable, my field. My field equal to my line of my field equal to split function. Split of tell me split of split the my line
by tab.
What is tab? Concentrate. We need to split my line, comma, delimiter within double quotes. What is the delimiter in this scenario?
Tab and comma.
Just a minute. Tab and comma. Where is tab?
Comma and space.
Comma and space. See, just a minute. Comma, space. Next, connect test data. See, by storing multiple values, we can make scalar variable as array variable. Here we are storing more than one value into my field variable. Two values, not only two. Suppose if it is 10 fields, 10 values, 20 fields, 20 values. Now my field is array variable. First value is agent name, second value is password. Next, connect the data. Connect agent name. After set, connect My field,
My field,
suppose if it is two values in array variable, what is the first value?
0.
0, good. 0, my field of 0. Next, my field of 1. See, if you want to observe the test execution process, insert wait statement. It is optional. Next, after loop, complete the formalities. First, close the file internally, obj textstream dot close. Next, release the memory for all two objects. Set obj textstream equal to nothing. Next, set obj fso equal to nothing. Run the script. Just a minute. Obj text stream dot at end of stream, end of the file, equal to false. See, first it is taking test 1, test 2, test 3, test 4. Next, last record test 5. See here, observe the logic. Do while. If we use while, here false. How? Obj text stream at end of stream means first it checks first line. First line is end of stream, false. Continue. Second line is end of stream, false. Third line, fourth line, fifth line. Suppose fifth line is end of stream, then it come out. Suppose instead of while, if we use until, do until, then what is the logic? Obj text stream dot at end of stream equal to true or false?
True.
True. True. See, now it is taking test 1, test 2, test 3, test 4. Next, last record test 5. Any confusion? See, this time we used all records. Suppose I want range of records. I don't want all records. Just a minute. See, 6, 7, 8, 9, 10. Suppose I want to read 5 to 8 records. Range of records. I don't want first 4 records and the last 2 records. 5 to 8 records. Otherwise, see, test 4 to test 7. Total 10 records in this file. I want to read middle 4 records only. I don't want first 3 records and the last 3 records. Got the requirement? See,
Yes.
read test data. See, range of records from 4 to 7 records. Here, condition required. Within the loop, condition required. I'm taking one more variable. Lines count. Line count. See, before the loop, initiate the variable line count equal to 0. Next, after my line count equal to line count plus 1. Next, write the condition if line count. Suppose I want to read from this one, this range of record. Now tell me, line count greater than, skip first 4, line count greater than 4 na.
Greater than 4, yes.
Next,
Greater than 4.
and line count less than
Less than 8.
8. Just a minute. Line count greater than 4. Next, compound condition, and line count less than 8. Then split and connect. Observe, run the script. See, test 5. It is taking test 5, just a minute. Already we used skip line method. You no need to skip. Condition is there. I want to read 4 to 7 records out of 1 to 10 records. See, test 4. Test 5. Test 6. Just a minute. Test 4. Test 5. Test 6. Why it is reading up to test 6 only? Less than 8. Condition is not sufficient. Less than or equal to, try. See, test 4. Test 5. Test 6. Test 7. Okay na?
Yes, sir.
Okay, cool. See, reading. See, we discussed reading character by character, reading line by line, reading all. Next, data-driven testing by reading test data from a text file. Next, writing examples. Writing. See. Write data to a text file. Write data. See, already objects are there. Just a minute. Writing also internal operation, text stream object is required. And for writing, write mode required. Default mode is read. What is the write mode? What is the file mode? Write file mode. We discussed file modes now. 1 for read, 2 for write, 8 for append. You need to remember. See, 2 for write. Next, suppose num1, num2 result. Num1 equal to 100. Next, using colon you can join statements. Next, num2 equal to 200. Next, result equal to num1 plus num2. Export the data. Obj text stream dot write method result. Don't use equal to. If you want any meaningful message, you can write addition of num1 comma num2 is concatenate result. Next, complete the formalities. Here no save method in file system object model. No save method. Object dot close. Close means save and close. See, set text stream object equal to nothing. Next, file system object equal to nothing. Run the script. Open the file. Observe, data exported na. Export means writing.
Yes, sir.
Cool. Next, run the script once again. Once again. It is overwriting na.
Yes, sir.
Overwriting. Just a minute. Suppose another statement. Subtraction. Run the script. How it is writing? Writing continuously na, not line by line.
Yes.
This is write method. Suppose if you want to write, just a minute, line by line, this is writing continuously. Next, I want to write line by line. See, write data. Line by line. Just a minute. Line by line we have to change the method. Write line method. See line by line na? Next, append. See, write means overwrite. Just a minute. See, first time num1 100, num2 200. Run the script. Okay. Next iteration num1 500. Run the script. Overwriting. Suppose I want append. What is the append file mode? E8. See first num1 100, num2 200. Run the script. Now appending na. Just a minute. See blank file. Next num1 500. Next num2 also 400. Run the script. Appending na. Did you observe?
Yes, sir. Yes, sir. I did. Yes.
See next one, small example, writing example. Observe. My requirement is open 1 to 10 orders. Open 1 to 10 orders and read customer name and tickets. Otherwise, and read order number, right side bottom. Read order number and customer name. See, my requirement is open 1 to 10 orders and read order number and customer name. Then export. Export means writing. Export to a text file. See, first generate the basic test.
Find the people, use this and little one to cast the people
Put mute.
and back in.
Next, read order number. It is disabled object, step generator. Show the order number object. Click OK. Next, get RO property of text return value. Take one variable, order number, insert. Next, read customer name get row property of text property, return value, or suppose C underscore name, customer name, close, stop. Next loop for I equal to 1 to 10, pass I as parameter. Next, create objects. Just a minute. Here only writing mode 2. Next, before loop, define field header. Field header is optional. Obj text stream dot write line field header order number customer name. Next, export the data. Say export order number and customer name, two fields into single line. Order number concatenate, suppose comma space, again concatenate, concatenation operator, join. Okay, enough. Next, complete the formalities. Here no save method. Generally for writing we need to save the file. In file system object model, no save method. Close method. Close means save and close. Next, set object equal to nothing. Next, set obj fso equal to nothing. Put base state and run the script. Observe this example. See, here we are using loop, but we are not closing the flight reservation window every time. At the end of the loop only. Suppose end of the loop, if you want to close this one, just a minute. After loop dot close. And you can generate login also. Login one time, open order 10 times, at the end close the application. Just a minute. Login one time. Close not required now. Just a minute. Log into application. This is one-time operation. One time. Next, open order 10 times. Next, close application. This is also one time. Did you understand the script? Any confusion? Hello?
Confusion, sir. I'm good.
See, login. Login one time. Next, over. Just a minute. If you want to observe, insert wait statement. It is optional. Run the script once again. Login one time. Open order 10 times. Within the loop. Open order only within the loop. Login and close application outside of the loop. Okay na?
Yes, sir.
Observe. Exported na?
Yes, sir.
Just a minute. Right line. Suppose okay, you send script, I will correct it. See, opening orders one by one.
So this is staying in the same page, isn't it? It's not going in another page.
No, same page.
Yeah. Okay.
See, observe. Exported na? Order number. Next I used comma space, then customer name for first 1 to 10 orders. See, not only same page. If you want to navigate 4 or 5 pages in your functionality, you can use, no problem. If you want to use single page, you can use. If you want to navigate multiple pages in your loop, you can navigate, no issue. See. Suppose if you want to navigate multiple pages, then comeback is required now for next iteration.
So you have to come back to that
Yes,
login
come
page
back to the,
and then
come back to the base state. Suppose here I am using only flight reservation window for opening order. Same window. Suppose in my functionality I am navigating 2 windows. For next iteration, I need to come to first window na.
yes.
That is mandatory.
Yes.
Okay. See next comparison example, concentrate, important example, comparison. Just a minute. See, here we have two files, UFT and ABC. Check the file size, 178 bytes, first file. Second file also 178 bytes. Just a minute. Here my requirement is read to compare two text files by size, by text, and by binary values, exact match. Text means not case sensitive. See, size is external operation. See, you no need to open the file. Just right click properties. Here you can get size manually. But textual comparison is internal operation. You need to open the file and read data. Next, binary values also internal. First you need to read the data and compare. See, compare two text files by size, by text, and by binary values. Understand the requirement?
Yes, sir.
Okay. See, file system object, variables, obj text stream. Next, you take file paths into variables, file 1, file 2, next file 1 equal to next file 2 equal to okay. Next, create file system object, set obj fso equal to create object of class value scripting dot file system object. See, first one, size comparison. It is external. No need to use text stream object. Using main object you can compare. Condition required. See, first comparison, compare two text files by size. Condition required. Condition. If obj fso dot get file of file 1 dot size property. size equal to footnote objfso dot get file of file2 dot size. Then you can write any meaningful message. MSG box, files are same by size, else files are not same. Next, release the memory. Set objfso equal to nothing. One more thing. If you want to display the file size, you can display. How? Say MSG box objfso dot get file. Observe, in this example working with multiple files. Previous examples working with single file. We can work with multiple files also. See, get file of file1 concatenate bytes. See, before also you can write message. Message optional. File1 size is next file2. Run the script. File1 size is, just a minute. Get file1 dot size property. Run the script. Observe, file1 size is 178 bytes. File2 size also same, 178 bytes. Files are same by size. Just a minute. You add one more letter. Now file1 size is 178 bytes. Manually observe. File2 size is 179 bytes. Run the script. File1 size is 178 bytes. File2 size is 179 bytes. Files are not same by size. Remove this extra letter. Now same. 178 files are same. Next, another comparison. Compare two text files by textual comparison. See, for textual comparison, we need to read the data. Here we have two files. See, in order to handle multiple files, multiple text stream objects required. Here two files, two text stream objects, one file. one text stream object. But remember, main object, file system object, always only one. Got this point? How to work with multiple files?
Yes, sir.
How to work with multiple files? Use multiple text stream objects. But file system object always only one na?
Yes, one, yes, sir.
See here we are going to work with two text files. Create two text stream objects. See. OBJ mute text stream 1 OBJ text stream 2. You can use multiple statements also optional. It is optional. See first OBJ text stream 1. Set OBJ text stream 1 equal to OBJ FSO dot open text file of file 1. Next, here file mode not required, read only. Read is option, read is default. See OBJ text stream file 2. Okay. Next, in order to compare two files, first read data, entire data into variable. Suppose read 1, read 2. Read entire first file data into variable. Read 1 equal to OBJ text stream dot read all. Read all. Next, file 2 data. Read 2. Text stream object 2. Next, compare. It is textual comparison. Remember string comparison function. String comparison function compares two strings. Here two files. No issue. We read the data into variables. You can compare variables. See if strcomp of read 1, read 2, comma, textual mode is 1 equal to, if both are same, 0. Next, write any meaningful message. MSG box. Files are same by text. Else files are not same. Next, one more comparison. Third one, binary values. Exact match. By binary values. What is the binary compare mode? 0. Otherwise you no need to write. That is default mode. See, observe. This 0 is binary compare mode. Next, the second 0 is result constant. See, files are same. Files are not same. Which one is perfect comparison? Textual comparison or binary comparison?
Binary.
Binary. Exact match. Next, release the memory. Just a minute. Dot close. Next, obj text stream 2. Close. Next, set obj text stream 1 equal to nothing. Set obj text stream 2 equal to nothing. Observe. First observe manually. 178 bytes first file. Second file. Second file also 178 bytes. Okay. First file 178, second file 178. Size comparison same. Next, textual. See, first file text, second file text same. Just I am changing the upper to lower, some letters.
4. Okay.
Now tell me the 3 inputs. Just letters case different. Observe the 3 inputs. What is the first output? Observe the 3 outputs. What is the first output? Compare 2 text files. Both are same or not?
Yes, same.
Same. Next, what about text? Textual comparison. Same or not?
Same.
Same. What about binary values? Binary comparison.
Binary is not same.
Not same. See, observe. Run the script. File 1 size, file 2 size. See, files are same by size. Files are same by text. Files are not same. See, binary comparison not same. See, this is about comparing two text files, flat files. Okay, now comparison example. Any confusion?
No confusion, sir.
Okay, cool. Say one more example is there. Search operations example that we will discuss in regular expressions chapter with the combination of file system object and regular expression object. We can perform search operations. Next, Excel application object model. Okay, just remember, so far we discussed create text file, copy text file, delete text file, read data, read 3 flavors, read character by character, read line by line, read all. Next, data-driven testing example. Next, write data, write continuously, write line by line and append. Next, comparison. 3 types of comparison. Compare 2 text files by size, by text and by binary values. Next, Excel application object. Excel object model. See here we create Excel application object. You know what is the purpose of Excel application object? See, it is used to perform operations on Excel application, or you can say Excel files. See, in Excel we have three entities: Excel application, next Excel file, Excel file, or you can say workbook. See, bunch of sheets: Excel file or Excel workbook, next Excel sheet, Excel sheet, or you can say worksheet, technical term, workbook, worksheet. See, three entities in Excel, three entities. Observe. Just a minute. A, B, C, D. Or you can say UFT. Observe, open the file. See, this is Excel. Just a minute. Close. Observe, it is Excel application. Excel application. Observe header. It is showing Microsoft Excel. It is Excel application. From Excel application, we can open and close Excel files. Next, open. What is that one? Just a minute. Desktop. Just a minute. Open UFT. Observe UFT Microsoft Excel. What is this one? This is Excel file na. Observe left side bottom. Excel sheets, sheet 1, sheet 2, sheet 3. You can rename sheets. See, this is Excel application. Close. Now tell me three entities of Excel. What are the three entities?
File, sheet.
Sequence required. What is the high end? Topper. What is the top unit?
Object.
Object.
Excel application.
Application. Excel application. Next, Excel file or workbook. Next, Excel sheet or worksheet. Okay, save. Next, create Excel application object. Application object. You know how to create common syntax for creating automation objects in your VBScript. Set. The set is VBScript statement. Variable equal to create object. It is built-in function of VBScript of class value. Class value only varies from one object model to another. Rest of the syntax same. Now tell me, what is the class value for creating a Excel application object? What is the class value?
Excel application.
Excel dot application.
Application.
Excel dot application. Okay. Next, come to examples. See, first example, create an Excel file, or you can say technical term Excel workbook. See, first declare variable dim obj Excel. You can take ABCD also, but take meaningful variables. Coding standards required. OBJ for object, Excel for Excel object. See, set obj Excel equal to create object of Excel dot application. Okay. Next, object dot visible property, visible equal to true. It is optional statement. What is the functionality of this statement? To view the operation during execution. If you don't use this statement, operation will be performed. You can get your output, but operation not visible. If you want to view the operation, use visible mode to view the operation during execution. Next, create Excel workbook or file. Obj Excel dot type W workbooks dot add. Say to create new file. Next, object dot active workbook means activate the workbook, select the workbook, active workbook dot save. If it is existing file, use save method. Just a minute. If it is new file, save as. Existing file, just save. Save as. Provide the path for storing. Suppose I want to store on desktop. Just a minute. Suppose UFT example dot Excel. What is the Excel file format? Latest format XLS old one, 2003. What is the latest one? Excel file format.
XLS.
Just a minute. XLSX na? Save as. Next. Object dot quit the Excel application. If you close the Excel application, file will be closed automatically. To close Excel application. Next, as usual, release the memory. Set object equal to nothing. Okay. Observe on desktop. Run the script. What happened?
Excel file created.
Excel file created. Name UFT example. Okay. Observe once again. Suppose comment this visible statement. What is the difference between previous iteration and current iteration? Difference between previous observe once again. See, first iteration visible, not true. I didn't use visible statement. By default visible false. Run the script. Okay. File created. Next, same requirement, visible mode. Run the script. File created. Now tell me what is the difference between these two iterations?
In the first iteration, when you commented that true, you couldn't see the Excel file created.
Yes, that operation not visible, but file created, isn't it? File created, but operation not visible. But
Yes.
in the second iteration, operation visible and file created. Anyhow, observe this object dot visible equal to true. Is it mandatory statement or optional statement?
Optional statement.
Optional statement. Suppose next statement, workbooks dot add. It is optional or mandatory?
Mandatory.
Mandatory. See. Next, observe on desktop, run the script once again. See error. What is the problem? Try to identify, locate the problem. What is the problem? File already exists now. Now enhance the requirement. Check existence of Excel file. If not exists, then create the file. If exists, don't create. Say checking existence, that is file system operation. See in this script, combination of file system object and Excel application object. Checking file existence, that is file system operation. Next, creating Excel file, Excel operation. See, obj fso, create file system object, set obj fso equal to create object of scripting dot file system object. Okay. Next, condition if obj fso dot file exists of file path. This is file system operation. If so and so file exists, negative condition, not exists, then create, otherwise don't create. If not exists, create and save. Not exists, create. If exists, don't do anything. One way condition, negative condition. Next, set obj fso equal to nothing. Okay. Observe on desktop, file exists or not? File exists. Run the script. Over. Next, delete this file manually. This time file not exists. It will create. Created na?
Yes, sir.
Okay, cool. See, tomorrow we will discuss read and write examples. Okay, next one more example. Today one more example. Check the existence of Excel file. If exists, then open the file, and enter some data. Next, if not exists, create the file and enter some data. Say here mandatory task is entering data. If file exists, open the file and enter data. If file not exists, create the file and enter data. Got the requirement? Any confusion?
Sir, yes.
File exists, just open the file and enter data. File not exists, create the file and enter the data. See, in this example also, file system object support required for checking file existence. Observe. If file exists, so and so file exists, then open the file. Then open the file. How to open? Dot open method. Add means create new file. Open means open existing file. Open of file path. File path. Next, enter some data. obj excel dot worksheets of, I want to enter data into first sheet, sheet 1 dot cells of 1, equal to VBScript. Then save. Else means file not exists. Create the file. You know how to create. obj excel dot workbooks dot add. Next, enter data. Next, save as. See, new file na. obj excel dot active workbook dot save as file path. Okay. Next, after condition, quit the Excel. Here we are writing the data now. Save already there. Quit Excel workbook. Okay. Observe on desktop. File already there, but no data. Observe sheet 1. First row, first column. No data. Run the script. Open the file. Data exported na. Export means writing. Observe the data. Next, file not exists. File not exists. It will create the file and export data. Run the script. Okay. Okay na? Two scenarios.
Yes, sir.
See. See, before going to discuss, tomorrow we'll discuss reading and writing examples. Here also in Excel object model also, sub and sub objects available. Here three important objects. Excel main object, Excel application object. It is main. Excel application object. Next, Excel workbook object. Next, Excel a worksheet object. How to create Excel application object? See, this is main object. Main object. Next, Excel workbook object. Sub object. Sub object for Excel application object. Next, Excel worksheet object. Sub object. Sub object for Excel application object and sub object for workbook object. Observe this first one, Excel application object, parent object. Next, Excel workbook object, child object. Excel worksheet object is sub-child object. Okay, three objects. And one more thing, in file system object model, creating sub-object, text stream object is mandatory in order to perform internal operations like read and write. But in Excel object model, creating sub and sub objects optional, only for user friendliness. Here not mandatory. Using main object, Excel application object, we can perform all Excel operations. But sub and sub objects only for user friendliness. But in file system object model, creating text stream object is mandatory for internal operations. We cannot perform read write operations on main object. Find the difference between these two object models in case of sub objects.
Yes, sir.
What is the difference? Tell me.
Creating sub object is not mandatory in case of Excel.
Excel. Using main object, we can perform all Excel related operations. But in file system object model,
it's mandatory.
Mandatory.
You cannot.
Okay. Tomorrow we will discuss creating sub and sub Excel objects and remaining Excel operations.